Good morning, students. Say, day before I have explained you the factors affecting the ionization energy. Now, anybody can define what is ionization energy or enthalpy. Then you told the minimum amount of energy required to lose the electrons from the neutral gaseous element. It is a successive process because an atom can lose one or more electrons, but one after another. So ionization energy depends upon the various factors: size of the atom, nuclear charge, a screening effect or shielding effect, exactly half-filled and fully filled electronic configuration. One question I would like to put to you, that why ionization energy one of beryllium is greater than boron? Why is ionization energy first ionization energy of beryllium is greater than boron, but second ionization energy of boron is greater than beryllium? Anyone can explain this fact? Although the atomic size of beryllium is greater than boron, so ionization energy is supposed to be smaller than the beryllium with respect to the boron. Actually, it is based on, you can see, the electronic configuration. First, to see the electronic configuration of the beryllium, it is the helium inert gas and its configuration is 2s2. Therefore, it is exactly the fully filled orbitals. Full filled orbital. Once you lose one electron from the beryllium, then it is the ionization energy 1. At that time, it is difficult to lose the electron from the beryllium. As such, it has a stable electronic configuration. Therefore, once you lose one electron from the beryllium, then beryllium becomes 1 positive and its configuration is now 2s1. But once you compare the boron, it is the 5, it is the helium, and this is the 2s2 and 2p1. So, see students, here what happens actually, p subset has 3 orbitals, 1, and it has only 1 electron. Therefore, it is easy to lose 1 electron from boron as compared to what? As compared to beryllium, because it is neither half-filled nor fully filled, it is actually incomplete filled or partial filled. But see the outlook of the beryllium, in its outermost shell or the valence shell, it has 2 electrons. It is fully filled orbital. Therefore, it is difficult to lose the electron, although the size of beryllium is greater than the boron. But ionization energy itself, first ionization energy, again the beryllium is greater than the boron. Once 1 electron is lost by the beryllium and then boron, it has lost 1 electron, then it becomes full filled 2s2 and it becomes only 1. Therefore, see, once you lose the second electron of the beryllium, boron, then ionization energy of second ionization energy of boron is greater than the beryllium, but first ionization energy of beryllium is greater than the boron. Actually, it is the structure of the electronic configuration. Right, I hope I have made it clear to everybody. Only you see the configuration and then you can be able to explain such kind of question. Now, after that, we are going to explain, electron gain enthalpy or electron affinity. So, dear students, see, now the next parameter or the periodicity of the periodic table, so far as down the graph across the periods, is the electron gain enthalpy. So here, electron gain enthalpy, or you can say electron what? Affinity. affinity. Either you can say electron gain enthalpy or you can say electron affinity. See, it is the unique property of a known metal. Whenever they gain the electron, that energy is lost and reaction is exothermic, and as far as stability of non-metal is acquired. But on the other hand, property of metal, once you provide the energy, they will lose the electron, energy is lost, they acquire the stability, but that is exothermic reaction. But here that was endothermic, sorry. Ionization energy was a endothermic process, because once you have supplied the energy and electrons are lost or rejected. But in case of the electron affinity, tendency to gain of electron, it is the property of non-metal, and then they attain the state of the stability and they have exothermic reaction. So how can you define the electron gain enthalpy or electron affinity? The amount of energy which is released due to addition of extra electrons in the outermost orbit of neutral gaseous non-metal is called electron gain enthalpy, or you can say, in short, you can write electron affinity. Right? See, the unit of electron affinity is kilojoule per mole or electron volt per atom. Similarly to the ionization energy, it is also a successive process, because they can gain one or more electron just one after another. For example, I say halogen, they need only one electron, it becomes halide ion. That can be fluoride, chloride, bromide, as well as iodide. So far as oxygen is concerned, first they will gain one electron, and again they will gain another electron, it becomes oxide ion, and they attain the state of stability like neon. And just like nitrogen, 3 negative. Right, so it is a successive process. An atom can gain one or more electron, but one after another. But see, it is easy to gain the one electron, and it is difficult bit to gain the another electron. It is again very, very difficult to gain the third electron. Just like once you correlate this fact with the ionization energy, it is easy to lose one electron from the sodium, it becomes sodium positive, but be difficult to lose 2 electrons from the calcium ion or magnesium, and again it is very, very difficult to lose 3 electrons from the aluminum. That is why there is a very good or great association of group 1 and group 17 of the periodic table. Why? To form a stable ionic compound, there is a good association of group 1 plus group 17. The reason behind it, 17 is the fluoro, chloro, bromo and iodo. They are extremely good non-metal because of they have a smaller atomic size in their respective period. So far as see, lithium, sodium, potassium, rubidium, cesium, they have very good association with non-metal, because it will lose one electron, it will gain one electron, it will lose one electron, it will gain one electron. That is why alkali metals, being the largest size in their respective periods from across LHS to RHS, they have very strong tendency to lose electron because they possess minimum ionization energy. On the other hand, extreme right, halogens before the inert gas, therefore they need only one electron to become halide, and they have a smaller atomic size. That's why they can form a very, very strong what compound? What compound? A strong ionic compound. See, on the other hand, you take the group 2nd and group 16. Again, they have a very good association to form again ionic compound like beryllium, like magnesium, calcium, strontium, like oxygen, sulfur, selenium. Like this, they have a very good association to form the ionic compound. So far as it is difficult to lose 3 electron and it is difficult to gain 3 electron, that is why they are predominantly covalent but partially ionic. But once metal will lose 1 electron and non-metal will gain 1 electron, like NaCl, KCl, cesium chloride, you see, and they form a very, very strong ionic compound. So they are mainly ionic and partially covalent, but once you increase the positive charge, like NaCl, like CaCl2, and like AlCl3, like KCl, CaCl2 or AlCl3, it is difficult to lose 2 electrons, it is difficult to lose 3 electrons, so that is mainly ionic but partially covalent, but it is mainly covalent but partially ionic. Reason behind is more the positive charge, lesser the ionic character, and vice versa. So dear students, so far as electron affinity is concerned, I give you one example here: fluorine, chlorine, bromine, iodine. See, in the gaseous state they will gain 1 electron, chlorine again gain 1 electron, and then bromine in the gaseous state will gain 1 electron, and iodine is, so far you can say, that is what it becomes: fluoride ion, it becomes chloride ion, bromide ion, gaseous state, and what ion? Iodide ion in gaseous state. So far as energy lost is concerned, minus 328 kilojoule per mole. So far as chloride ion is concerned, minus 349. Point to be noted here, it's very, very important point here. It has maximum negative electron gain enthalpy. And then bromine, delta H, minus 325 kilojoule per mole, and here again the kilojoule per mole, and delta H is minus 2, that is the minus 295 kilojoule per mole. So one thing is very important here, that reaction is exothermic because energy is lost, delta H becomes negative, and chloride ion becomes neon. Chloride ion becomes isoelectronic species with argon, bromide ion becomes krypton, and then iodide ion becomes xenon. They have nearly, the similar character like stable electronic configuration like noble gas. So, but one thing is here is that one question is very important. Although the size of chlorine is greater than fluorine, but electron affinity 1 of electron affinity, here it will gain only 1 electron. So simply write electron affinity of chlorine is greater than fluorine. Although we know that electron affinity is inversely proportional to the size. As a rule, down the group size increases, so electron affinity decreases. It's fact. But so far as size is concerned, dear students, down the group size going to increase. Fluorine becomes in the 2nd period, chlorine 3rd period, bromine 4th, and iodine 5th, and statin 6th. Statin is a radioactive element, so we will not consider. But why this question is like this? कि यदि साइज इसका ग्रेटर है तो इलेक्ट्रॉन एफिनिटी कम होना चाहिए एज कंपेयर टू द फ्लोरीन. But reason behind is the see, fluorine does not contain d orbital, while chlorine contains d orbital. So the size of fluorine is smaller than chlorine, thus the p orbital in fluorine atom is oriented in a smaller region as compared to chlorine. As such, addition of extra electron in fluorine causes repulsion. Fluorine causes repulsion. Thus, electron affinity of fluorine is greater than fluorine. See, once I give you the picture of fluorine, so no need to write in the paper. It is more than sufficient to write the question. If question comes, why the electron affinity of fluorine is greater, chlorine is greater than fluorine, then you have to explain like this. See, to elaborate your knowledge, fluorine 9, which is the nucleus, is the first cell and it is the second cell. This is the 2 and 7 electrons. Addition of extra electron causes repulsion because of the dimension of fluorine is very, very small. Therefore, it is difficult to adjust an upcoming electron comparatively as compared to chlorine, because it is a comparative study, right? But so far as chlorine is concerned, it is 17, is the 2, 8 and 7. There are 3 energy levels. So it is the nucleus first cell, second and third. This is the 2, 8 and 7. Addition of extra electron can be easily adjusted and no repulsion because of the size of chlorine is greater than fluorine, although the electron affinity of chlorine is again greater than the fluorine, because of fluorine does not have d orbital, vacant d orbital, but chlorine contains vacant d orbital. It is the matter of fact that the electron affinity of chlorine is greater than fluorine. Keep in mind. So, but the question is, why the electron affinity second or third is always, what is that? Positive. This is a question. Because of electron affinity, second is always positive. Reason behind is, for example, you take the oxygen atom. In the oxygen atom, here it is the 8 and its configuration is 1s2, 2s2 and 2p4. It is the helium and then 2s2 and 2p4. Actually, apply the Hund's rule and then you, it has the 2 unpaired electrons, right? Now once you provide the 1 electron, this is the electron affinity 1 and it becomes oxygen 1 negative, right? Then its configuration is 2s2 and 2p5, 1, 2, 3, 4 and like this. Now once you provide the other electrons, then these electrons will repel to the upcoming electrons. When these will repel the upcoming electrons, it is because of oxygen 1 negative is isoelectronic with fluorine, And fluorine, again, you remember, tendency to repel the electron due to the smaller p orbital oriented in a smaller region or a smaller area. As such, the electron affinity first is alright. There it becomes delta H negative. But dear students, here once you provide the other electron here, electron affinity second, and once you provide the other electron, then it becomes, see, oxygen 2 negative, and it is the state of the stability like this 1, 2, 3, 4 and 5, 6. But delta H is positive because the reaction is, what is that? The reaction is endothermic. The reason behind it, once you have supplied the external energy to minimize their repulsion and to maximize their stability, as such electron affinity second and so far as third is always positive. But electron affinity first is always negative. Whenever you provide the other electron, then it becomes positive and reaction is endothermic in nature. So the question again arises, what factor attributes the electron affinity? So no doubt you can see the factors affecting electron affinity. First is the atomic size. So atomic size is electron affinity or electron gain enthalpy is inversely proportional to the size of the atom. Down the group, size increases, so electron affinity, what is that? Decreases, right? Except you can see chlorine is greater than fluorine. So far as group 17, it is the group 17. So far as group 16 is concerned, the phosphorus is greater than sulfur. Sulfur is greater than the phosphorus. And group 15, you remember, sulfur is greater than oxygen, and here phosphorus is greater than the nitrogen. Same situation will be applied: chlorine, fluorine, oxygen, sulfur, phosphorus and nitrogen. It is the question of group 15, it is the question of group 16, and it is the question of group 17. Right? Just the same answer will be whatever I have explained you. But along the period, no confusion, no change in trend. Trend is already made fixed, and along the period, I mean across the period, from LHS to RHS, along the period, size, what is that? Decreases due to increase in what charge? Nuclear charge, and hence electron affinity, what is that? Electron affinity increases, like boron, carbon, nitrogen, oxygen, fluorine. So it is what actually fluorine has the more, like sodium, magnesium, aluminum, silicon. So better to say p block elements, right? So you take the aluminum, silicon, phosphorus, sulfur and chlorine. No doubt in their respective period, chlorine has very, very high ionized energy. But down the group, chlorine is exceptional case. That is why its value is delta H minus 349 kilojoule per mole. But so far as chlorine is concerned, delta H is equal to minus 328 kilojoule per mole. Down the group there is some change, like fluorine, chlorine, like oxygen, sulfur, like nitrogen and phosphorus. Take group 15 in mind, group 16 in mind and group 17 in mind. It's alright. So the factor 1 is the atomic size, is alright, and second is the nuclear charge, that is the force of attraction. between electron and the nucleus. More the nuclear charge, higher the attraction, and lower the size, and more the electron affinity. Third is the, you can see, penetration effect. So far as penetration effect is concerned, the attraction between the nucleus and the electrons, so more the penetration, S has more penetration than P, then D and then F. More the penetration, a smaller the size, and more the electron affinity. Electron affinity of inert gases possess very high due to stable electronic configuration. Electron affinity of, oh, it's all right now. So far as the electron affinity is concerned, that the half filled, fully filled, as well as the inert gases, they have very, very high electron affinity because they have very less tendency to gain of electron. Right, graphically you can represent here that the electron affinity. Take one side you write here atomic number going to increase, and this side it is this side you can say electron volt, या kilojoule per mole. This is the electron affinity. So here I write here 275, difference 25, 300, 325, this is the 325, and this is the 350. So here fluorine, chlorine, bromine and iodine. It is the fluorine, chlorine, bromine. Better to write here atomic number 9, 17, 35 and 53. So dear students, 349 is the case of, 328 is the case of, see fluorine here, but it is the fluorine, and then approaching 350 it is the 390 is the case of chlorine, then 325 is the case of bromine, and then it is the case of iodine. Fluorine, chlorine, bromine and iodine. What the value is actually here is the fluorine is minus 328, chlorine is minus 3, minus 325 minus 328 and minus 295. Sorry, what the values you have written here? This is the fluorine is minus, bromine is minus 295, minus 328, 325 minus 320, 349, sorry, this is the 328 minus 349 minus 295 and minus, but the value just I would like to see the minus 328 minus 349 minus 325 and minus 295. This is what actually the value of, so it has the maximum electron affinity. So dear students, just you put down it is fluorine, chlorine, bromine and iodine, like this. That is why it is the exceptional trend so far as fluorine, chlorine, bromine and iodine is concerned, right?